All right, we want to take a look at graphing a rational function. Here we have a rational function, f of x, equal to 6x squared minus x minus 2, all over the quantity 2x squared plus x minus 6. Now we could take advantage immediately. Let's take a look at this in factored form. 6x squared minus x minus 2 is indeed factorable. 3x minus 2 and 2x plus 1. Checking the middle terms, negative 4x plus 3x does indeed give me that negative x. 2x squared plus x minus 6, our denominator. In factored form, we'll have 2x times x, and we can go with a negative 3 and a positive 2. That'll give us that coefficient of x for our middle term. Notice none of these divide out. So we're not going to have any holes in this graph. We are going to have asymptotes for sure. So first we can take a look at our vertical asymptotes. Vertical asymptotes are going to occur wherever the denominator is equal to 0. So I'm interested in when is 2x squared plus x minus 6 equal to 0, and conveniently enough we already have the factored form, 2x minus 3 times x plus 2 equal to 0. Well, only something times 0 equals 0, so it must be true that 2x minus 3 is equal to 0, or that x plus 2 is equal to 0. Solving the resulting equations, adding 3 to both sides, we'll have 2x equals 3. Dividing, we'll have x is 3 halves. That's the location of one of my vertical asymptotes. The second equation, subtracting 2 from both sides, we know that x equal negative 2 will provide the second vertical asymptote. Question to look at now is, will we have a horizontal asymptote? So for our horizontal asymptote, we want to take a look at the degree of the numerator and the degree of the denominator first. In our case, the degree of the numerator is exactly equal to the degree of the denominator. They're both squared. They're both quadratic. So I know I can divide out the coefficients. So our horizontal asymptote would occur where y is equal to 6 divided by 2, or we have the horizontal line, y is equal to 3. So I know where my asymptotes are located vertically. I know the horizontal asymptote. There's still a little more information that we can pull from this problem. Do we have any zeros, for example? And remember, a fraction is 0 only if the numerator is 0. 0 over a number is okay. So I'm interested in when is 6x squared minus x minus 2 equal to 0, the numerator equal to 0. We have that guy in his factored form, 3x minus 2 times 2x plus 1, and setting each of those factors equal to 0, we know that either 3x minus 2 is equal to 0 or 2x plus 1 is equal to 0. Solving each of these equations, adding 2 to both sides, 3x is equal to 2, which means I would have a 0 when x is 2/3. My second equation, equal to 0, subtracting 1 from both sides, I know that 2x is equal to negative 1, and dividing by 2 on both sides, I have another 0 where x is negative 1/2. So what we have found are x-intercepts, if there were any x-intercepts. We have found 2. Now, one final piece, let's take a look at any y-intercepts. Our vertical intercept is kind. We're looking for what happens if x is 0. So we're just looking at f of 0. F of 0 for our fraction. Plugging in zeros for x's leaves me nothing except a negative 2 in the numerator and a negative 6 in the denominator. So I know f of 0 is 1/3. We finally have our players. Now we're ready to sketch a graph of this function.
Morning, sir.
We want to start graphing our function. First, we'll take a look at the vertical intercepts we found earlier. We had vertical asymptote at 3/2, so that's 1.5. So I have one vertical asymptote at x equals 3/2. We will have another vertical asymptote where x is equal to -2. And so from the first thing we looked at, next we took a look at horizontal asymptotes. We did have horizontal asymptote where y was equal to 3. And so we have our form for our function: horizontal asymptote at y equals 3, vertical asymptotes when x was -2, and when x was 3/2. Now we did pull more information from this function. We found zeros, x-intercepts, when x is 2/3, so 2/3 of the way between 0 and 1, and also where x was -1/2. This helps a lot because we rarely know exactly what the middle of these rational functions are going to behave like. The end behavior we can tell based on our denominator. Now, I also had a y-intercept, a vertical intercept, at 1/3. And so I'm pretty confident of what the middle of my graph looks like. Because it's bounded by these asymptotes, this must be a function that curled up, crossed the x-axis, hit the y-axis, and then crawled back down again. But what about the tails? Thinking about this was quadratic in the denominator. So when we think about our end behavior, this is the last piece to look at. This has even degree in the denominator. And so it should have that same end behavior. And so I would expect it to reflect on the left and on the right side of our asymptotes, and that makes me feel pretty good, because if you think about 1 over x squared, 1 over x squared has that same end behavior. Because we had the two asymptotes, we have different behavior in the middle of the graph, but that's where the vertical intercepts and the horizontal intercepts helped us out immensely. So we have our full graph of our rational function. All right.